All right, ladies and gentlemen, welcome back to the drive-thru. Hungry? Stop by the deli. Make yourself a rare roast beef and Cajun chicken sandwich on potato bread with provolone and some barbecue husband chips and a pickle spear and some frosted sugar cookies. All right, this is Chapter 2-6, the multiplication and division properties. If you didn't understand the addition and subtraction properties, then you should not be paying attention to this lecture. You should be going back to the addition and subtraction properties. Because as you probably know, multiplication and division are just shortcuts for addition and subtraction. I hope you understand that. Like the first caveman was like 5 plus 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 5 is 50. And then the second caveman was like, no, 5 times 10 is 50. And the first caveman was like, blind, mind blown, multiplication invented. Right there like that, Jenny. You feel me? Yeah. All right, now get back to work. Okay, so pretty simple. There's just 2 theorems, but really they could be 4 theorems. This is just like yesterday. So if you followed yesterday's video, this one's going to be very similar. If segments, or angles, are congruent, then their like multiples are congruent. We can refer to this as the multiplication property or the multiplication theorem. Okay? So we got options. The second theorem for the day is if segments or angles are congruent, then their like divisions are congruent. We can call this the division property or the division theorem. Now these are the only theorems for the day. Okay? So let's figure out when we're going to use them. So I've recopied those 3 hints out of your book. Okay? So number 1, look for the use of the words midpoint, bisect, and trisect more than once. Okay? If you see those words used more than once, you are absolutely going to use the multiplication or the division properties. And then if the resulting segment or angle is bigger, you've multiplied. If the resulting segment or angle is smaller, then you've used the division property. So that's what these are saying. All right, are you ready to try a couple? Yeah, good. You're so excited to watch this video. Excellent. All right. Given MK is congruent to FG, and KG bisects MJ and FH. Well, notice, 2 things are being bisected. So when we see that 2 things are being bisected, we're going to get in the habit of thinking about the multiplication or the division properties. So, step 1, I'll write down my givens. MK is congruent to FG, and KG bisects 2 things. It bisects MJ, and it bisects FH. Okay? That is given. Well, we can go right to the final conclusion here. This is a 2-stepper. Okay? I can conclude that MJ is congruent to FH because, well, since 2 things have been bisected, that means we can deduce that MK is congruent to KJ, but that FG is congruent to GH. However, these were congruent in the first place, which means these must be congruent, and therefore the entire big segments must be congruent to each other. Has the segments gotten bigger or have they gotten smaller? They've gotten bigger. So our reason will be multiplication theorem. Any idea what people are going to do wrong on the test for this reason? Yes, they could call it division. What else do you think people do wrong? They call it addition. Wonderful, Jenny. Okay? It's not addition, because what does bisect mean? To divide into two equal parts. And what's the opposite of division? Multiplication, not addition. You hear me? All right, good. One more harder example. All right, so the givens are all right here. I'm going to squiggle them because there are so many of them, okay? Oh, yeah, I did. Where's my proof? I don't even have a proof written down yet, do I? I better make an adjustment to this. Look what I just learned. Pause feature! Whoa! There it is. It's amazing. It's right there. It was there the whole time. I don't know what you guys are looking at, but it was there the whole time. We are clearly, Jamie, trying to prove that angle NSO is congruent to angle RTP. We're trying to prove that these two angles are congruent. All right, so we know that angle NOP is congruent to angle RPO. Notice I didn't mark them as right angles because they didn't tell me anything about them being right angles. Okay?
What are angle 1 and 3?
Ooh, let's put angle 1 and 3 on there. Thank you. Clearly, you can see angle 1 and 3 have been there the entire time, Grant. I don't know what you were looking at, okay, but they were there the whole time. All right, so we've got NOP is congruent to RPO. PT bisects RPO. So I'm putting all that. That's my givens. You are not allowed to do that. I'm saving us a little time today, okay? So, step 2. What I want to do is I want to utilize this piece of information right here. Okay? So, we've got two angles right here that are marked in red. Okay? And they are congruent to each other. But then they both get bisected. So how is angle 1 related to angle 3? Very good. Angle 1 is congruent to angle 3 by what? No, not anymore. Definition of bisect would say that angle 1 was congruent to angle 2. But that's not what we're saying. This is the difference between definition of bisect and angle division property. Is this angle division or angles? It's angles. Because two angles have been divided. But I don't think that matters. I would never take off a point because of the lack of S. Okay, now, what's that? It's both. Okay? So, now what can we say? Well, this is kind of nice. It says that NSO is complementary to angle 1. But RTP is complementary to angle 3. But if two angles are complementary to congruent angles, then how much must these two angles be related? They are congruent. You either understand that or now you've fallen 2 days behind. And I hope I'm not trying to scare you, but it just gets like a snowball effect in here. Okay, you've got to stay up. Because now most of us understand that angle NSO is congruent to angle RTP because of what? Congruent complements theorem. Boom!